So this is the last video from chapter 11 and also from 11.3, and it is called Solving Radical Equations Still, However, with Extraneous Solutions. And I'm going to show you what that means as opposed to just going through the definitions. In short, the solution that you find from the equation doesn't work. And I took both examples from the textbook. So I took example 4 and then I took this guide example number 5 just because I think they're really helpful examples to understand, does this make sense in my answer, yes or no. So to start, the first thing we had to do, just like the first two videos, is you have to square both sides of the equation because I want to get rid of this square root on the left-hand side. So by squaring both sides, I eliminate the square root, and I'm now left with 6 minus x is equal to x squared. Now there's not much we can do here, but I want you to recall what we learned throughout chapter 9. And what we did in chapter 9 was we solved different quadratic expressions by factoring first. And we did that by also setting those equations equal to 0 when there was an equation format. So what I want you all to think about doing is moving all of these terms on the left-hand side to the right because I want the equation to be equal to 0. Do not move x squared to the left because you're then dealing with a negative in front of the x squared, and that makes your answer and work much more difficult. So by moving the x to the right-hand side, I can add x, and remember you can't combine x squared and x together because they both don't have the same exponent. And then I can subtract 6 from both sides because that's the inverse of a positive 6. And now there's nothing left on the left-hand side of the equation. So just to rewrite it so it all looks fluid and easy to understand, we have x squared plus x minus 6 is equal to 0. Now from here, you have to recall what we did when it came to factoring quadratic expressions, and more specifically, when I used the X-man work method as opposed to what your textbook showed. So what we're going to do is create our X-man, and I want two numbers that when added together equal 1, and when multiplied together equal -6. And I'm hoping that you came up with the two numbers that when added equal 1 and multiply equal -6 are -2 and +3. And then we went ahead and created our two binomials. So we took the first one and said x minus 2 times x plus 3. That's supposed to be an x. And we set them equal to 0. And how did we figure out what the values of x were that makes this entire equation equal to 0? And we did this before we left for our distance learning process. I told you to break out both the parentheses and say x minus 2 equals 0 and x plus 3 equals 0. Sorry, the work is a little messy. And then you solve for x. So to solve the one on the left-hand side, the inverse of subtraction is adding. So we added 2 on both sides. And one of our possible solutions is going to be +2. And on the right, the inverse of adding 3 is subtracting 3. And we are left with x is equal to -3. Now in this section, I know it's a lot of work. We aren't sure if either of these answers are going to be the solution to this example that we were given. So we have to check, is one of them an extraneous solution, which means it doesn't work in this equation. So we're going to plug back in both of them individually and see if we get the correct answer. So the original expression that I had written down for number 1 was 6 minus x equals x. So I'm going to first test, well, does 2 work? So we're taking, does the square root of 6 minus 2 equal 2? So you're just plugging in the value of x in two different spots. 6 minus 2 is 4. 2 remains the same. And is the square root of 4 equal to 2? Yes. So that works because 2 equals 2. Now I'm going to check, well, does -3 work in this expression up here, or this equation? So that would look like 6 minus negative 3. Remember, the subtraction sign does not take the place of a negative number. And does that equal negative 3? So we plugged in our x value to the two locations it is in the equation. And then we were left with what is 6 minus negative 3, and that's equal to 9. And then we have negative 3. What is the square root of 9? 3. Does 3 equal negative 3? No. So that means that negative 3 is an extraneous solution, and 2 is the solution to the equation. If you don't want to continue watching from here on out, you can go ahead and start the assignment, but I am going to show another video dealing with extraneous solutions. And this one is 3x plus 4 is equal to x. So again, to start off, you're always squaring both sides to cancel out that square root, and that cancels out. So we are left with 3x plus 4 is equal to x squared. And again, just like in the last example, I want to move everything on the left side to the right because I want to keep x squared positive, and I also want one side of the equation to equal 0. So to remove the 3x, the opposite of the positive 3x is negative, so we're subtracting 3x from both sides. And the inverse of adding 4 is subtracting 4 from both sides. And then just to rewrite it, we have x squared minus 3x minus 4 is equal to 0. Then we want to factor this because we don't really have any other solution to get this answer by itself. So I want to know what our two numbers when added together equal negative 3 and when multiplied together equal negative 4. I'm going to let you think for a second. And hopefully you came up with 1 and negative 4. And then you break those up into two binomials. So we have x plus 1 and x minus 4. Remember, we just take the two arms of our x-man and throw them into our binomials. And we set that equal to 0. And then from there, we have our two individual expressions. So we have x plus 1 equals 0. And we have x minus 4 equals 0. Wow, this is terrible handwriting. I'm so sorry. The inverse of adding 1 is subtracting 1 on both sides. So we're checking, can x be negative 1? Or can x be the inverse of subtracting 4 is adding 4? Or can x be equal to positive 4? So once again, I'm going to rewrite the original expression. 3x plus 4 equals x radical over that. We are going to plug into two different equations, negative 1 and then 4. So in the first one, we're going to be checking if negative 1 is a solution. So we have 3 times negative 1 plus 4 equals negative 1. Then we're dealing with 3 times negative 1 is negative 3 plus 4 equals negative 1. Then we're at the square root of 1 equals negative 1. And I hope you notice that the square root of 1 is positive 1. So negative 1 does not equal 1. This is not a solution. This is an extraneous solution. And then if we check the second one, we are going to have, that was aggressively large radical, 3 times 4 plus 4 equals 4. Again, we're plugging in the x values that we solved for. So then we have 12 plus 4 equals 4. And 12 plus 4 is equal to 16. Does the square root of 16 equal 4? Yes, it does. So that means that the value of x equaling 4 is a solution, but negative 1 would be an extraneous solution. And again, there's more of the definition within the textbook. So if it doesn't work, it's considered an extraneous solution. I know it's a lot of work. I know this video was long, but good luck with your homework.